awesome.
Okay, here we go. Properties of logs.
Society.
You guys, now I'm going to kind of go backwards with this. This is page 174 of your student journal. I got to say that I thought this exploration was a little confusing. So I want to just emphasize if you decide to go through this later, that make sure you really pay attention to this information up here. That is huge. It tells you what x and y equal. Okay? So after today, if you want to see if you really, really get it, I would try to use this to prove some of the properties that I'm going to give you today. Okay? I'm not going to actually work through it with you. I will have the answers up here, though. All right? So what I really want you to do is look at page 176. We're going to talk about the properties of logs. Okay? So I've already referenced one of these as we've been working through. There are three properties and then one formula we're going to talk about. Okay? First, the power property is one that I've talked about a few different times. I've said, look, if you have a power, so if you're taking log of a log base something of something and you have a power, that really what you could do is you could move that power outside and you get n log base b of m. So for example, let me give you an example here. If you have, sorry, that's really blurry. Okay, there we go. So if you have, say, log base 3 of 7 to the 4th power, okay, you could rewrite that as, why don't you guys rewrite it? Okay, really what we do is we move that 4 out in front. It jumps out there, and we get 4 log base 3 of 7. They are the same value. If you're like, are you sure, Mccoy? You like really sure about that? Well, maybe try it with the base 10 and put it into your calculator, which you should be able to do. Okay, you should find that if this wasn't base 3, if we just got rid of it and just called it base 10, log of 7 to the 4th should equal 4 log 7. You should get the exact same value if you put them both into your calculator. Anyone checking me? Did you get the same thing? I don't want to be lying to anyone. You didn't get the same thing? Whew. One person got it. Stas, you get it? Good. That's a powerful property, man. Just saying. Okay. In the product property, I want you to use the same numbers that we just used. Let's say I have log base. I think I need a new camera. Okay. Let's say, what did I have here? 3? Okay. Let's say I have log base 3 to the m times n. Okay, let's make m, what do we want to make m? I guess this is actually b here. Let's call, we don't want to call them all 3. Maybe we use base 10 this whole time. That way you can check. Yeah. Let's use base 3 on these, okay? So, or excuse me, base 10. That way you can check them. You can see that I'm not lying to you. So let's call it log base 10 of 5 times 7. Okay? What would that equal if you're using the product property? Okay, good. Log base 10 of 5 plus log base 10 of 7. Notice they have the same base. You have to have the same base. So if you were to do log of 35, that should equal log base 5 plus log base 7. Throwing it into your calculator, check it out, see if I'm right. Yes? You could just say log. Yeah, I'm just saying base 10 for what we're doing right now. But yep, you could just say the log of. Did it work? All right. And subtraction property, rather than rather than multiplying like when we add, we, for the quotient property, we divide. I think I called it the subtraction property. We divide here. And I don't have room over there, so I'm going to write it down here. But if we use the same thing, log, what do we want m to be this time? 9 of, or log of 9 over 4 is equal to log of 9 minus log of 4. Okay, see if they work. Yeah.
So we just have like inverse properties of exponents? Because like when you do exponents, you subtract and divide?
That's a good point, yeah. So as Sylvia's pointing out, like when you're dealing with exponents, when you subtract, you divide. When you add, you're multiplying, right? Like I believe you're talking about like if I had 4 to the, or let's use x. Say I have x to the third times x to the second. I would just have x to the 2 plus 3. So yeah, it does have stuff to do with that. That is why we're going through this, because when we're in exponential form, you're dealing with that. Yeah. Good thinking. Okay? How many think you're there? Those are our properties. We want to memorize those properties. 3 properties. We also have what's called the change of base formula. So those of you like, how am I going to do these on my quiz if I don't know how to, or on my test if I can't use a calculator and I have like log base, I've got log base 4 of 9, and I want to know what log base 4 of 9 is. Well, what you do is you use the change of base formula. And this looks way complicated, but really all it says is no matter what your base is, you could take your base, okay, and put it on the bottom. So that would be log of 4. Thank you. So the bottom number goes to the basement. The base. Okay. And this one goes up here. Log of 9. Notice it is not log of 9/4. It's log of 9 over log of 4. Okay? And you can make it whatever base you want. You could say, okay, I don't like base 4. However, I'm a big fan of base 7. So I'm going to call them both base 7. Fantastic. You can do that. Okay? You'd be like, I really, really like base 23. Just like Kinsey. Okay? However, a lot of times we just use base 10. Why? Because our calculator works in base 10, and that's what base we function in our numbering system. Or base, what is this? Or base E. So really they're saying, hey, if you have this, you could, they kind of summarize it saying usually we use this. That's the natural log of C over the natural log of A. Or the log of C over the log of A. The small number goes low, the big number goes high. Okay? That's the change of base formula. All right. Any questions there? All right. Let's try some of these then. We're going to work through the second part of the exploration. It's actually the third part, I guess. It's the bottom of page 175 of your student journal. So if you take a look at that, we're going to apply some of these properties now. Use the properties of logs that you derived in explorations 1 through 3 to evaluate each log. Now remember, if you want to go back to explorations 1 through 3, you can kind of do what we did, which is prove that they work. That's what they're trying to get you to do there. I just thought it was more confusing than we needed. So let's check this out. Tell your neighbor what property you would use on this one.
Power property number 1.
Okay, how many say product, quotient, power? Yes, it is power. How do you know it's power? Matt, how do you know? Okay, you have your, what you're taking a log of going to a power. How else do you know it's not product or quotient? Autumn? Yeah, you're not multiplying or dividing anything. Okay, so let's bring this out here. That is 3 log base 4 of 16. Are we done? Evaluate means you're coming up with a single number there. What is log base 4 of 16? 4 to what is 16? Yeah. 2. Times 3 is 6. Isn't that neato? Just did it in our head, man. It is neato burrito. I want you to try letter B. That'd be a good one. What is that? 4. Matt? No. Just go 3 to what power is 81? 4. And times negative 3 is negative 12. Okay. Okay, tell your neighbor what, well, first, any questions on A and B? What property are we going to use on C? Tell your neighbor. Okay, once you know, go ahead and rewrite it. Okay, you guys, I kind of tricked you on this one. You have to use 2 different properties. Are you taking the natural log of the same thing? The same letter, right? But why aren't they the same? Powers are different, right? So we first have to apply the product property, or the power property. So let's rewrite it as 2ln E plus 5ln E. And now, notice you're adding the same exact thing. So you can solve this 2 different ways right now. You could say, whoa, I have 2 natural logs of E, and I have 5 natural logs of E. I'm adding the same things. How many natural logs of E? 7. Some of you may just go, well, hold on, I know the natural log of E. Natural log of E is log base E of E is what? It's 1. This is just 1. My answer is 7. Okay? So maybe you figured that out here. Maybe you figured it out right here and you said, well, 2 plus 5 is 7. Okay? But the first thing, you cannot combine anything until you're taking the log of the same thing. So like on letter D, can I combine ln E to the 6th and ln E to the 5th? No. So the first step is to apply the product property. And what's that make that right there? 12. Yeah. It's 2 times 6. Minus. That would be 5. Oops, I forgot the E on that one. Yeah, it's 7 again. It's so boring. 7 ln E, that part's 1. So the answer is 7. Okay. Any questions there? Last 2. Letter E. All right. Log base 5 of 75 and log base 5 of 3. Are you taking you have the same base, are you taking and dealing with any powers in this one? No. So in this one, we can go ahead, since we have the same base, okay, and no powers, you can go ahead and put those together. What rule are we using? The quotient. So that is log base 5 of 75 over 3. Yeah, which is 25. Good. Log base 5 of 25 is 2. Okay. Go ahead and finish that last one real quick. I'll put the answer up in a minute. Okay. Product property. Log base 4 of 2 times 32, which is log base 4 of 64. 4 to what power is 64? Any questions? All right. So you guys, you have your puzzle time there. I'm also going to get your pre-quiz. Okay, it's just the book chapter quiz.